Find the average rate of change of the function over the given interval. The first thing that we need is to recognize the average rate of change formula. It looks very similar to the slope formula. Remember the slope formula? We had that was m equals y2 minus y1 over x2 minus x1. It looks very similar. Here we have x2, here we have x1. Remember, f of x is the same thing as the y value. So f of x2 is like y2, f of x1 is like y1. So the slope and the average rate of change are very, very similar, and we calculate them in a similar manner. For part A, we're looking at the average rate of change of the function over the interval 0, 2. This is our interval right here. It's in the brackets. So this is our starting point at 0, and this is our ending point at 2. And these are the values that we will put in where we see t throughout our function. So let's try this. The first thing that we need to figure out is what g of 0 is equal to, because 0 is our first endpoint. So that means that we put 0 in everywhere that we see a t. So take out the t, put in a 0 in its place. If we solve this down through, 0 to the third is 0, 2 times 0 is 0, 4 times 0 is 0, 0 minus 0 is 0, plus 1, we're going to get 1. So this means that g of 0 equals 1. Let's do the same thing again, and this time let's find g of 2. So this means everywhere that we had a t before, we take out the t, we put in a parenthesis, and in the parenthesis, we put a 2. So if we calculate this one out, 2 to the third, that means 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. So 2 to the third is 8, times 2 is 16. 4 times 2 is 8, and then plus 1. So 16 minus 8 is 8, plus 1 is 9. So that means that g of 2 is equal to 9. Now we can figure this out. We have all of our different pieces. So our function evaluated at our second x. So right here, our function evaluated at our second x. That's this one. So our change in y over our change in x is going to look like our function evaluated at our second x. So that is our 9, minus our function evaluated at our first x, our function evaluated at our first x, and that's going to be 1. All over, we have our x2, so that's going to be our 2. And then we have our x1, and that's going to be our 0. So we have everything substituted in, and now we can simplify. 9 minus 1 gives us 8. 2 minus 0 gives us 2, which leaves us with 4. So the average rate of change of our function over the interval from 0 to 2 is 4. Let's try again for part B. This time our interval is from 4 to 8. So we're going to do the same thing that we did before, and we're going to figure out what c of 4 is equal to, and then we'll figure out what c of 8 is equal to. So let's start with c of 4. So everywhere we see an x, we take out the x and we put in a 4. So we're replacing it with this 4 value. Take out the x, put in a 4, and then we have plus 2. So if we simplify this down, 4 times 4 on the top gives us 16. 4 plus 2 on the bottom gives us 6. We should simplify our fractions, so 8 over 3. For x equaling 8, that will look like 4, take out the x, put in the 8. On the bottom, take out the x, put in the 8. Simplifying down, 8 times 4 is 32. And 8 plus 2 is 10. We should always reduce our fractions, so that gives us 16 over 5. So now we can figure this out. Our change in y over our change in x, or our average rate of change, is our f of x2. So that's going to be our 16/5 minus our f of x1. So that's going to be our 8/3. All over x2, so that was 8, minus x1, and that was 4. So we need to do a little bit of work here so that we can simplify these fractions. We need a common denominator, so we need to multiply this one by 3, top and bottom, and we need to multiply this one by 5. We do that so that we get a common denominator of 15. If we have a common denominator of 15, then we can subtract our numerators. So do a little bit of multiplying, a little bit of subtraction, double check your work, and you should get 8/15. And then in the bottom, we have 8 minus 4, so that is 4. I like to make it over 1 so that when I flip and multiply, I have that denominator and I can use it to flip. So here we have the complex fraction, so we need to flip the bottom, flip and multiply. Simplifying, and we're left with 2/15. So our average rate of change is 2/15. Let's try part C. So we are given, and change color so it doesn't blend together. H of t equals 1.85 times 3 to the t. That's our function. Our interval is 2.9 to 4.1. So we need to figure out h of 2.9, and we need to figure out h of 4.1. So I have 1.85 times 3 to the 2.9. And this one looks like it will be 1.85 times 3 to the 4.1. So simplifying down, type this one into your calculator. It looks like we will have h of 2.9, excuse me, 2.9 equals 44.753. And h of 4.1 is equal to 167.251. So same thing, our change in y over change in x is going to look like 167.251 minus 44.753 all over 4.1 minus 2.9. And do a little subtraction, do a little simplifying. I'll go ahead and convert it to a decimal. You should get 102.082. So this is how we find the average rate of change of a function over a given interval.